But by accident, this drug has been shown in tens of thousands of veterans, and mainly, but tens of thousands of people, to also delay other diseases of aging, heart disease, cancer, frailty, Alzheimer's. It's amazing when you look at now. It's associations. So for the aficionados, we don't know for sure if it does that. But this is the closest thing we have right now to a drug that slows down aging.
And what is going on with metformin? What's the mechanism?
Yeah, it's well, part of it's the boosting of the mitochondria number and raising the energy. But it's got other benefits. It's anti-inflammatory as well. And to be honest, as I should be as a scientist, we don't know. There's other stuff it does, but we just know that people who take it, a diabetic who is sick and often overweight, who takes metformin, on average lives longer than someone who doesn't have type 2 diabetes and doesn't take the drug.
Really?
That is an amazing statistic.
That's insane.
Yeah.
So it literally not just mitigates the effect of diabetes, but it enhances your lifespan past the point of a person who doesn't have diabetes.
On average.
On average.
Yeah.
I like how you just hedge your bets there. So what's going on with metformin? What is it doing to the body, and how is it doing it?
Well, it's going to inhibit the energy production, and the body will start to make more. So you'll have more energy. You'll have...
it inhibits the energy production. How so?
How so? Okay, how deep do you want to go?
All deep.
Let's go deep.
Let's go.
All right, so the
Put my scuba
mitochondria...
goggles on.
All right. And stop me if I get boring.
You're not boring.
So in the cell, right? So let's zoom down into a cell. A cell is a bag. We break through the membrane, the bag, outer bag, and now we're in liquid. Now we're swimming around, and there are these weird shapes that are floating around. They look a little bit look like Mike and Ike's. Is that what they're called?
Mike and Ike's?
Mike and Mike's? Little tubes. The candy.
Oh, Mike and Ike's. Okay.
Yeah,
okay.
I'm Australian, so
Okay.
I talk about other things, but Cadbury chocolate and stuff. Okay, these are little
we all know
tubes.
Cadbury chocolate.
Do you do?
Yeah, sure. It's famous.
Okay, got it.
Cadbury eggs, right? Yeah.
Yeah, so the Cadbury eggs floating around the cell. They look more like an extended little tube.
Okay.
And they are what we use to make most of our energy. When we eat sugar or aminos, they get transported into the mitochondria and they get converted into energy. So how does that work? I'm glad you asked. The mitochondria have another couple of membranes. So now we're going to pierce through the outer one, and now we're going to swim in between the inner and the outer membrane. What's happening is that's really acidic. It's a lot of protons in there, and the cell's pushing them into there, and that builds up this gradient of pH, so it's acidic. And then those protons that are in there, they want to get back inside that little thing, and so they can't get through, but there are these little holes, which is a protein called ATP synthase, and when they bust through that hole, it's like a propeller, like a hydroelectric generator on a dam, and they shoot through, and this thing spins around and makes a chemical called ATP, which the body needs to survive. That's where we get all our energy. If we don't have ATP or this little spinny thing, we're dead in less than 30 seconds. You take cyanide, that's what it does. It blocks that process.
Oh, wow.
So it's needed for life, and it seems the more you have of that, the better. Now, one thing that one of my companies that I'm helping and I've invested in, to be honest, to be transparent, is developing is a way to punch holes in that membrane so that the hydroelectric dam is less efficient. So we've got a leak in the dam. And so not all the energy is going through. So what we see happen in animal studies is that they can eat more food and not gain weight. It's a perfect weight loss pill.
Wow.
So I want to help cure obesity as well.
That sounds very Dr. Oz-like, though. It's a perfect weight. It's a miracle. It's a miracle pill.
Well, it seems
Kinda
like a
sounds
miracle.
like.
I don't believe in miracles, but I believe in good science. And in the 1920s, mostly women who were in these factories, actually it was earlier, World War I, they were making bombs. And there was a chemical called DNP, dinitrophenol, which has this property to break through this hydroelectric dam wall. And those women were really skinny. And people didn't understand it. And they found out that if you eat this molecule, DNP, you shed weight. And this started to be sold
How are they
in
eating the
hospitals.
molecule?
Well, they're breathing it in, and that was sufficient.
Really?
Yeah. So then it became sold. It became one of the best-selling drugs. Yeah, I think it was 1928, something like that. And people thought that this was the end of obesity. And, people were partying in the streets, basically. But the problem is when you bust holes through that membrane, it generates, as a byproduct, heat. And people took too much because they wanted to get thin really quickly, and they overheated and some of them died. And that led to
Whoa.
the FDA Act. And this is why we have drug regulation.
That's why?
One of the main reasons, they shut that down because it was killing people.
How many people died?
Oh, not that many, but still, one is too many.
But it's an overdose issue.
Right, and you can still get it on the black market. They used to give it to
Mm.
Russians, apparently, in World War II to stay warm.
Wow.
But if you're wondering, David, why are you making a drug that's going to kill people? Well, actually, the chemists are working and have made molecules that are sensitive to this acidity, and if it gets too low, it'll turn itself off.
Why don't you just let people figure out the right dosage? Let them get warm.
Come on, there are always stupid people who are...
There are, and you need to let them. You need to let them be stupid. That's a part of the problem with today. We nerf too many corners. Some people need to bump into the ends of the world. Donk, ow!
Yeah.
You can't have everything cushioned.
Well,
then you don't
this
learn.
is the problem, because also we've got so many people who need help, and
Yes.
it's a trade-off.
Yes. It is a trade-off.
risk. Everything's a risk. Every drug. There's no safe drug.
Yeah. It's but we need education, but we also need these fascinating things like this.
So let me tell you some of those other traits that make us different from animals.